wanted today to share my journey exploring using machine learning for sports coaching. And specifically, I wanted to share with you how I've been using edge devices to support that. So devices not in the cloud, but actually devices in the field. The sport I'll be using today is cricket, sport close to my heart, but I really want you to be able to see how this could easily be applied to other sports as well. So firstly, a little bit about me. So I look after emerging tech and innovation at Mantle Group. I've been there over 3 years, and in that 3 years I've been supporting Mantle Group's machine learning business, Eliza, as their CTO. I'm very serious about cricket, as you can see in this photo, holding some equipment that I bought 20 years ago. These days I don't play so much cricket, but support my son with coaching his cricket. So I'm going to cover a fair bit of ground today with the ML approaches I've been using to bring together a coaching sports solution. I'll quickly cover some of the basis of using video for sports analysis and some computer vision techniques as well. But then I'll move into the ML techniques that you're probably really interested in. And these are things like body pose, where the body's moving, shot detection, so how do we know what people are doing in the video shot, and how to bring all that together into a useful coaching tool that we can use actually out in the field. So firstly, a little bit about coaching with video, and particularly within a cricket scenario. So sometimes it's hard in cricket to see or know where your technique needs to be adjusted. The bowling action and the batting action, even fielding, is actually quite fast. And as a coach, being able to see that is quite difficult without slow motion. And even as a player, like, you don't know if you're doing something wrong until you actually see it. So I've been using slow motion video capture for quite a while to show kids how they're bowling and how they're batting and where they might be able to improve. For batting, I want to share with you some of the things we look for here. So we look for a good head position. We look for the head to be nice and straight and level. We want to make sure that the body movement is moving towards the line of the ball as it comes, and that the batter actually makes a good shot selection. By that we mean they choose the right shot to play. Do they play it straight or do they play it over that way? And they need to do that very, very quickly depending on which ball has been bowled. And for the bowler, we want to see really consistent bowling. So in the graphic here, you can see a really consistent set of bowling where the bowler has been able to group all the balls within the same spot very, very consistently. They're at the consistent length and they're at a consistent line as well, straight down the wicket. And to do that, we really need to make sure that, again, the bowler's in a good body position when they're moving through that bowling action. And slow motion video analysis is really useful to slow down that and work out what's going on. Is the arm in the right spot? Is the head tilting back? And how we can correct some of those things. So when it comes to taking the next step and I guess automating a lot of that work that I've been doing around analyzing slow motion video, I wanted to dip into a bunch of techniques that we now have access to on these devices to, I guess, help automate that process and bring that together a bit more efficiently. So computer vision on mobile has seen a lot of advances over the last few years. We're getting bigger and bigger GPUs on these mobile devices, and now we're even getting specific machine learning hardware. So on latest iOS devices, Apple devices, you can see neural engines coming into the fold as well. Camera quality is getting higher and higher on these devices. We're getting better resolutions at higher frame rates for our video, meaning we can do better processing on them as well. The machine learning frameworks are finally catching up, and we're getting machine learning frameworks that are targeted specifically for mobile devices that have constrained battery, that have different processing units on them. And not only can we run machine learning models on there, but we can actually do things like train new machine learning models. And we can even manage our models and deploy them and update them on these mobile devices. And all of these things really come together along with some of the existing computer vision APIs that are on these devices to really give us these big experiences. And for me, I really saw this come together at the recent Apple developer event, so WWDC 2020, where they released iOS 14. The picture in this slide here is an app they built to really demonstrate bringing together multiple machine learning techniques on the device to actually run and score a game. So in here they're playing a game of cornhole where you throw a sandbag into a hole, and to score it, it's able to work out if the ball landed in the hole or not, what speed it did, and even how the player actually did that. Did they throw it overarm or did they throw it underarm? And when I saw this being presented and the APIs available, it really triggered in me what opportunity I could use that to bring that to other sports. So I want to build up a couple of these techniques into a complete coaching app and show you how I've done that along the way. And to do that, we're going to start with something called object tracking. So you can see in this video here, there's something moving through the air. It's moving in a nice parabola shape, and we're able to detect that movement through something called frame differentials. So to do that, we take each frame of the video and we look at the difference between each frame. And if there's a difference between each frame, then we can detect that something has moved in that frame. So in this particular scenario here, we can see there's something being thrown at the top, we can see an arm moving, and we can see something along the bottom as well. So we're only interested in that object, that ball or that sandbag that's moving at the top. So then we apply some additional techniques around object filtering to let the APIs know that, look, we're only interested in an object that is no bigger than this and is no smaller than this. And this allows us to filter out things like the arm movement and the shadow, which is the object movement at the bottom of the screen. This is not a machine learning technique, this is a computer vision technique. And by that I mean we're not training a model on data. There's no reason why we couldn't look at using an object detection technique, but this object tracking technique has proved to be quite successful. This is a video that builds on that technique and does something called trajectory estimation. So what we've done here is we're looking for where those objects are moving and trying to build them into a form of a parabola, which a ball would fly through. This video shows me bowling, the flight of the ball, and importantly what we're trying to achieve here is where did that ball land? We're even able to detect a second bounce, so a second parabola where it goes from down to back up again, and that point where those two trajectories join is the point where that ball is landing on the pitch. And if you remember back to the earlier slides where I talked about how we want to judge how a player is bowling or batting, these are really good automated techniques for us to do that. Furthermore, once we've detected that trajectory, we can actually store the parabola that created based on the coefficients for a parabola. So the equation for a parabola is ax squared plus bx plus c. We can store a, b, and c in a database and then be able to recreate that on the screens, so we don't have to store kind of the raw data. Next, I used a technique called body pose estimation, and you saw some of this in the previous video. So in this video we can see individual body points, which are the dots being detected as a player is actually moving through a bowling action. And then I've been able to group those into particular segments around their eyes, the hips, shoulders, and legs and arms. And this is really useful to be able to detect a lot of movement issues through a very fast action. So for a bowler, I really look for a steady eye line. You can see at the end of this clip here, the bowler's eye line is actually nice and level, so their head is quite steady as they let go of that ball. We can also look for other things as well, like balance and body weight transfer throughout the bowling motion. We can also use that body pose information with batting as well to determine what shot is being played. So this video here is my son playing a straight drive, and the body pose information is useful to help firstly understand if his technique is correct or not. So in this shot, I'd probably suggest he wants to bend his elbow a little bit more so the ball doesn't go so high. And if his head is over the line of the ball or not. But additionally, what I've been able to do is use that body pose information to determine what shot he's being played. So I can tell this is a straight drive here, but I can actually, and have trained a machine learning model to look at all of that body pose information and translate that into a prediction about what shot is being played. Is it a straight drive, or is it a cut, or is it a hook? All different shots like that. And the way we do this is we capture those body pose information over a series of frames, in this case 45 frames, and each one of those frames, it forms a sequence of body pose movements. And when we train a model and say a straight drive looks like a sequence of body movements like this, then it helps the machine learning model understand that that's a typical movement and shape that you would see if they're playing this particular shot versus another shot. What I want to use this particular technique for is to be able to work out how many times a player plays a certain shot, and if they're playing the right shots for when the ball is landing in those certain spots on that pitch. And I want to do that in a really automated way as well. Now, again, to kind of support the automation of what I'm trying to do here is that I don't want to have to log into the app and register which player I'm working with, because when you're coaching kids playing cricket, there's probably 30 kids running around, and having to work out who's batting at the moment and write the results down against each person is actually quite time consuming. We can use some simple, again, off-the-shelf facial recognition models to actually build player recognition. And this is what I've done. So I've built up a bit of a database of different players in the team, and being able to recognize each one as they come in to start batting or they come in to start bowling. And then when I see them play a shot or bowl in a certain way, I can record that information against the particular player themselves. Now, initially I was a little dubious about whether this would work or not, particularly with the amount of equipment that you wear in the sport. You can see in the shots here that I've actually made sure that we used helmets to see if it detects the right people or not, and it certainly does. What I did find, however, was that there's a point where the resolution of the camera gets so low that the detection starts to not work. So a little bit of a concern here, but in the testing I've done so far, that this actually works quite well. So as we're talking about some of the challenges, I want to lead into, I guess, where I've ended up going with this solution. And I want to highlight some challenges I've found along the way and some of the solutions that I've managed to start putting in place. So firstly, you'll see in this video here that the trees are moving slightly in the background there. Now, that's not great for that first technique we talked about around object tracking, where we track differences in each frame, what has moved in each frame, to detect if there's a particular ball movement or not. So to help support that, we do some filtering, like I mentioned before, around object size. But when those movements are around the same object size that we're looking for, we can use other techniques as well. And so we can use an area of interest. So I can limit the area of interest to the pitch area there to help with that information as well. But sometimes that camera angle is just not perfect for what we need to do. You can see the one I've chosen there is straight down the pitch, right next to the chains, and that's not a great angle for what we need to do. I actually need the angle to be out of the way for a start. So all this was done with a camera on a tripod. What I really want to do is be able to mount these cameras. So if you look at up the top of the cage there, you can actually use a really good spot to be mounting cameras down towards the batter, but also a multiple camera system where I can mount a camera back towards the bowler within the same computing unit. These are all things that I can't do with the mobile phone. And finally, what I saw using the mobile phone as a test bed for this, I guess, was that it generated a lot of power, and outside in the sun, it gets very, very hot and won't last very long. And so I guess for me, the mobile phone was a good kind of inspiration and prototyping ground, but I really needed to come up with a more permanent solution if I wanted to build this any further. And in fact, I have. So moving towards a bit of a pilot system now as we move into the cricket season. Mobile's been useful, like I said, to inspire the idea and prototype, but we really need to look at a more kind of permanent or semi-permanent solution. So what I've come up with here is using one of these NVIDIA Edge devices. So these devices here are basically an embedded Linux device with a great big GPU on here that's really optimized to run machine learning models. And further than that, these devices are actually very, very good at being connected into cloud environments. So connecting into AWS's IoT Greengrass to be able to manage code on the device, so when I want to update it, and models on the device as well. Because what I'm talking about here is deploying this in a field up high where I can't reach that device all the time, but I want to be able to iterate quite quickly over the length of the pilot over summer. And so building a mechanism where I can now deploy these models onto this device and update them quickly has been really, really useful. Also, being able to bring models that I've built in my prototyping stage on the device and use them within this NVIDIA device has been useful for me as well. So I've been able to take the body pose and shot selection models and then move them into Amazon SageMaker. So SageMaker's allowed me to train my models there based on the data I'm collecting, but also to be able to deploy them back out onto the edge devices themselves. And that's been really, really useful. And finally, this particular device here, I've got a single camera on it today, but they support multiple cameras. So I can actually use that single device and point it back across towards the batter and the bowler. So once I've collected all that information on that device itself, using the cloud environment, I'm being able to store the players, I guess, information and statistics about how they're playing back on a back-end database. And this is where I can use the mobile and become quite useful into a coaching app. So I'm building an app that will allow me to see at an aggregated level how well this batter played versus how well this bowler bowled, and then dig into that next level of data if I need to. So I wanted to thank you for listening through that, and I hope it inspires you to try out these sort of solutions for the sport of your choice, and feel free to ask me some questions and I'm happy to answer them. Thanks.